In this lesson, our objective is to solve quadratic equations that model real-world scenarios. And we can solve by a variety of different methods. It doesn't really matter how we solve, although sometimes there are some methods that are better than others. This is just the state standard that's really there for your teacher to understand why he or she is addressing this subject. For our first scenario, Alex will catch a ball that is thrown to him from a treehouse. This is the equation that models the scenario. H is feet above the ground and t is seconds. Alex will catch the ball when it is 5 feet above the ground. After how many seconds will Alex catch the ball? So if we're looking for how many seconds, that's the value of t. We're looking for the time, which is the same thing as the x coordinate. So we're going to sketch out this scenario, and you certainly don't have to sketch it like I'm sketching it. I mean, the tree is really not the important part. But here is that tree house right here, and there must be somebody in the tree house. Maybe it's a girl, and she throws the ball, and then here's Alex, and Alex, there he is, he's wearing a ball cap right there. He's going to catch the ball right here when it is 5 feet above the ground. So we could write an equation that would be used to answer this question. Well, you might say, well, we already have an equation right here, but how does the 5 fit in? Well, if it's 5 feet above the ground, that means that it's the value of h. So I'm going to take this 5 and I'm going to substitute it in for h. 5 equals negative 16t squared plus 6t plus 15. There's our equation. Now, how many methods can be used to solve this problem? Well, there's lots of different ways. The first way could be technology. You can use technology to graph this scenario. Here is the equation that we just wrote. Here is the 5 that it is equal to. You could go into Desmos, so you could use your graphing calculator. If you were to graph this equation, because it has a power of 2, that would be the parabola. And then you could graph the other equation. Because this doesn't have a variable with the 5, this would be a constant equation that would go across like that. That would be y equals 5. And then you could use your graphing calculator or Desmos to find the place where the green and the pink graphs intersect. And the x coordinate where they intersect would reveal the number of seconds when Alex would catch the ball. We're not going to demonstrate this in a calculator right now. You have that available for you if you want to use it. The other two methods are a little bit more important for this lesson. Let's talk about quadratic formula and about factoring. So we have the equation 5 equals negative 16 t squared plus 6t plus 15. And it says, since this equation is not equal to 0, why do we need to set it equal to 0? Why do we need to subtract 5 from both sides so that the equation is then equal to 0? If you remember from previous lessons, we talked about the fact that every x-intercept has a y-coordinate of 0. So whenever I am looking at a graph and I have an x-coordinate here, the y-coordinate then would be 0. So whatever input for t I have for this function, I want the output to be 0. I know that up here, it was when he was 5 feet above the ground. But by subtracting that 5, what you're actually doing is you're looking for the x-intercept. And this is just the mathematical way that you do it. And if you remember, for quadratic formula, you have the formula x equals negative b plus or minus the square root of b squared minus 4 times the a value times the c value all over 2 times the a value. For factoring, you would take the equation that is set equal to 0, again, because solutions, which come from factors, come from the x-intercepts, and you would ask yourself, is there a GCF? Yes, it's got to be negative. And what number divides evenly into negative 16 and 6 and 10? That would be negative 2. Dividing that out of each term, you would have at squared minus 3t minus 5. And then you want to figure out what are the two factors that multiply together to make this trinomial. Stop your video here and see if you can figure out how to use the quadratic formula and factoring on your own.